Good evening, everyone. Today we are going to discuss that is types of redox reactions, class 11 CBSE chapter. One of my student he want to join. That is why I have choose this chapter. See, see, first one is that is see types of redox reaction. That is first one is combination reaction. Like we can say which reaction in which two or more than two atoms or molecules combine together to form a new substance, it is known as combination reaction. Combination reaction. Next, what we can say that is general formula A plus B gives rise to C. We can show. See, like I have written already A plus B and A plus B gives rise to C. Then after that, once again, if you take carbon, any another equation if you take, that is the first one is carbon, and carbon is gas. Then oxygen also it is, we can say that is gas. Then carbon dioxide also it will form, that is new substance. Okay. Then carbon plus oxygen, it is carbon dioxide giving. This is one type or one of the combination reaction. Then once again I am repeating this definition. Those reactions are which reactions in which two or more than two atoms or molecules combine together to form a new substance. It is known as combination reaction. Then example is carbon plus oxygen gives rise to carbon dioxide forming. Then this is one of the combination reaction. Then second one is that is decomposition reaction. Decomposition reaction. What we can give that decomposition reaction definition. Decomposition, see, this is all combination, decomposition, displacement, double displacement, these all are, we can say that is from 10th class chapters, like 10th class chemical reactions and equations chapter only, based on 11th class CBSE chapter, that is uh, redox reactions. Redox reactions, like decomposition reaction definition. What is the decomposition reaction? Those reaction in which a molecule break down to give two or more substance, it is denoted by, like we can give, for example, A compound is there. A compound is in the presence of heat. It is splitting B compound plus C compound. If it is splitting, that is we will call decomposition reaction. See, here I want to take one example, that is like water molecules you take. That is water molecule is A compound. Compound A. Water molecule is one of the compound A. In the presence of electrolysis, then it will split H plus oxygen. That means H plus and plus oxygen it is splitting. That means hydrogen and oxygen atoms it will split. Then hydrogen is a B compound plus oxygen is C compound. That is we will call decomposition reaction. Decomposition reaction. See, after I am writing here, in this notes. Then after completion of this class, then I will send one to one your WhatsApp number. You can send me your WhatsApp number, then I am going to send your people, whoever you need these notes, I am going to send. But I am writing right now. But that is why for writing purpose it will take time. That is why very slowly we can go through live stream. See, decomposition reaction I written those reactions in which a molecule break down to give two or more substance. It is denoted by, like we can give single substance water molecules in the presence of electrolysis, hydrogen plus oxygen it will split, then this is known as decomposition reaction. Okay, is it clear? Then next, see, if you have any doubt you can comment, and I am watching only. Whoever if you need, then I will respond and I will give proper answer also. The next third one is displacement reaction. Displacement reaction, we can give which chemical substances or which one ion or atom, ion or atom in a compound is replaced by an ion, replaced by an ion. It is denoted by we can give, for example, substance A plus substance B, if you add substance A plus substance B, if you add, then gives rest. It is going to form, it is going to give A compound or B compound plus C compound, it will give. That is general equation. But I am going to take one simple example, then I will explain. Like we can give decomposition very, in every lab it is available copper sulfate I will take, like blue color crystal, blue color crystal it is available every in lab. That is why I want to take that copper sulfate compound, CuSO4, that is blue color crystal compound. Then copper sulfate, whenever in the presence of, like we can give copper sulfate CuSO4 plus zinc rod, in the presence of zinc rod, then it is going to give Cu copper plus ZnSO4 it will form. Okay, here A compound is copper sulfate and B compound is zinc, then gives rest copper plus zinc sulfate. Zinc sulfate, that means that exchanging their radicals, like Cu plus SO4 minus, then Zn plus. Then it is copper is eliminating. Copper is eliminating, then it is forming zinc sulfate. Zinc sulfate. That is we can give. Then any another example I want to give one more. That is, see, once again I am repeating, displacement displacement reaction. Displacement reaction. What is the definition of displacement reaction? Which chemical substance are those reaction in which one ion or atom in a compound is replaced by an ion? It is denoted by copper sulfate plus zinc gives rest copper plus ZnSO4. Zinc sulfate it is giving. This is one of the displacement reaction. Displacement, how it is happening actually, if you take reactivity series comparison to zinc, copper is very less reactive, very less reactive. That is why copper sulfate is blue color substance. That blue color substance it is displacing by zinc, then it is going to form ZnSO4 plus Cu copper. Okay, that is the displacement reaction. Then I written definition, even example also I written, then I will forward your, then next your WhatsApp number. Then next fourth one, that is, which is fourth one, like we can say displacement reaction are divided into two categories. We can divide two categories also. One is metal displacement and another one is non-metal displacement. We can divide that also. See, I am also that also I am going to give very clearly. Why? Because we have a lot of time and slowly we can discuss like this manner. See, first one is, that is metal displacement. Metal displacement. Metal displacement. See, metal displacement, a reaction in which a metal in a compound is displaced. In a compound displaced by another metal. By another metal in the like uncombined state. Uncombined state, it is known as metal displacement. Metal displacement reaction. See, I am writing here slowly. Once again, I am repeating reaction. Reaction in which reaction in which a metal in a compound is displaced by another metal in the uncombined uncombined state. State. Uncombined state. Then here example is we can give like sodium. Sodium is one of the metal. Sodium. Sodium is solid. Two sodium atoms you take. Two sodium atoms plus two water molecules you take. 2H2O we can write. 2H2O. Then gives rest. We can write it is going to form 2NaOH. 2NaOH is one of the base. 2NaOH is one of the base. 2NaOH aqueous plus H2 hydrogen gas. Hydrogen gas. That means here physical states also you have to identify. Like this you have to identify. See, sodium and sodium is solid. Then another one is water molecule. Then it is going to form NaOH, sodium hydroxide. Sodium hydroxide is aqueous. Then hydrogen also gas. Okay, this is one of the like non-metal displacement. Sorry, this I given example is non-metal displacement reaction. Metal displacement reaction, another one I am going to give, that is HCl or copper sulfate. You take copper sulfate and zinc. Copper sulfate and zinc, Cu and ZnSO4, that is we will call, we given already metal displacement example. See, metal displacement example is, that is CuSO4 copper sulfate plus CuSO4 copper sulfate is aqueous state. Then zinc is Zn, zinc is solid. Then it is going to give copper solid plus ZnSO4. This is we will call metal displacement reaction. Then second one already we given, that is second one non-metal displacement. Non-metal displacement example is sodium and water molecule. Then sodium hydroxide it will give, then hydrogen gas. That is non-metal displacement. Non-metal displacement. See, which is I given first one. By mistake I written here, because metal displacement is two metals we have to take. Like copper is metal, then zinc also metal. Copper sulfate plus zinc, then it is going to give copper plus ZnS for zinc sulfate. That is metal displacement reaction example. Then another one is non-metal displacement reaction. Non-metal displacement reaction is, one is metal, sodium, then water molecule is non-metal, then it is going to give sodium hydroxide plus hydrogen gas. That is. Then next, disproportionation reaction. Then fourth one, see, which is types of chemical reaction, like we can say, that is types of redox reactions. Types of redox reactions. First one is combination reaction. Second one is decomposition reaction. Then third one is displacement reaction. Displacement reaction, there are two types. One is metal displacement, and second one is non-metal displacement. Then next, fourth one is disproportionation reaction. Disproportion disproportionation reaction. Disproportionation reaction. Okay. Disproportionation reaction. Then see here, a reaction in which reduction or reaction, I am writing definition first. A reaction in which reduction in which reduction and oxidation takes place in the same element of the same compound. Same compound. Same compound. See, a reaction in which reduction and oxidation takes place in the same element of the same compound, it is known as disproportionation reaction. Disproportionation reaction. See here, I am going to take hydrogen peroxide, H2O2. Hydrogen peroxide. Example is H2O2, hydrogen peroxide. Then it is going to give H2O, water molecule, plus 1 by 2 oxygen. 1 by 2 water. We can write that is H2O2 hydrogen peroxide, and it is going to give water molecule plus 1 by 2 O2. So, repeat again. Yes, disproportionation reaction, sir. Disproportionation reaction. That is a reaction in which reduction and oxidation takes place in the same element of the same compound. It is known as disproportionation reaction. Then here I am taking here hydrogen peroxide. Hydrogen peroxide formula is H2O2, and water molecule and oxygen it will give. Then here we can say that hydrogen peroxide, whenever it is giving water molecule, hydrogen peroxide to water molecule, that is we will call reduction. Then hydrogen peroxide to whenever it is forming oxygen, that is we will call oxidation. Okay. Then this is we will call disproportionation reaction. Then next, here how we can balance. Then another one is we can say, like another example also you can take, like chlorine gas, and in the presence of hydroxide, then it is going to form ClO and Cl minus and water molecule. That is also we can give example. If not required, one is enough. Then we can go balancing of redox reaction. 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 See, first one is that is balancing of redox reaction. First one is oxidation number method. Oxidation number method. And second one we can give, that is ion electron method. Ion electron method. Ion electron method, that is we can say off reaction. of reaction method. Okay. Then next fourth, that is like we can say first one is oxidation number method. See, balancing of redox reaction, there are two types: oxidation number method, and another one is ion electron method. Ion electron method. Oxidation number method. Oxidation number method. We are going to discuss oxidation number method. Oxidation number method. That is, what are these steps I am going to give? See, first step, write the redox reaction for all reactants and products of the reaction. Then second one is indicate the oxidation number of all the atoms in each compound above the symbol of element. Above the symbol of element. First point, write the electron. Write the redox reaction for all the reactants and products of the reaction. Then second point, that is indicate the oxidation oxidation number of all the atoms in each compound above the symbol of element. See, once again I am repeating here. See, oxidation number method is second point, that is indicate the oxidation number of all the atoms in each compound above the symbol of element. The next third point, identify the elements which undergo change in oxidation number. The next fourth point, calculate the increases increase or decreases. Calculate the increase or decrease. Calculate the increase or decrease in oxidation number per atom. Then next, another point, calculate the increase or decrease oxidation number per atom. It is over. Then next, another point, that is equal the increase in oxidation number with decrease in oxidation number on the reaction side. On the reaction side, by multiplying formula of oxidizing agent and reducing agents with suitable coefficients. That is another point. See, next, I think this is the fifth point. Equal the increase in oxidation. Increase in oxidation. See, I am also writing. Your people also kindly write. Otherwise, I can send also. I will send equal the increase in oxidation number with decrease in oxidation number on the reaction side by, sorry, on the reaction or reactant, on the reactant side by multiplying formula of oxidizing agent and reducing agent with suitable with suitable coefficients. Then next, sixth point. This is then balance the equation. With balance the equation with respect to all other atoms except hydrogen and oxygen. The next, last point, that is finally balance hydrogen and oxygen. Finally balance hydrogen and oxygen for balancing oxygen atoms and water molecules to the side deficient in it. Then balancing of hydrogen, balancing of hydrogen atoms depend upon the medium. See here, for reactions taking place here, actually these all rules, so we have to give a lot of here rules are there. That is why it will take time. For reactions taking place in acidic solutions, add H plus ions to the side deficient in hydrogen atoms. For reaction taking place in basic, whenever we are adding basic solution, add H2O molecules. Add H2O molecules. Those points also very important. I am writing. I am writing. I am going to write the 2 points for reactions. You can put or note these 2 points. Why? Because important points. Note for reactions taking place for reactions taking place in acidic solution, add H plus ions to the side deficient in hydrogen atoms. Then another one, that is for reactions taking place in basic solutions, add H2O molecule, add H2O molecule, add H2O molecule to the side deficient in hydrogen atoms and simultaneous simultaneously add equal equal number of OH minus ions on the other side of equation. Other side of equation. Other side of equation. This is today we given, that is balancing of reaction. First oxidation number of oxidation method. Then next class off reaction method we have to discuss. Off reaction method we have to discuss, that is second point. I'm writing heading off reaction method. Off reaction method. Here off reaction method once briefly I will discuss, and after that I will close. Off reaction method. See, we can say that off reaction method also indicate the oxidation number of each element above their symbol. Here we can say off reaction method is we have to indicate the oxidation number of each element above their symbol. Then next, find out the species which are oxidized and which are reduced. Which are oxidized and which are reduced, we have to find out. Then third point, split the equation into two off reaction. That means oxidation of reaction and reduction of reaction. We have to split. Then we have to add balance to off reaction. As we can say, that is balance all atoms except hydrogen and oxygen. To balance oxygen atoms, H2O molecule are added in deficient side That means where oxygen atom are less. Where oxygen atom are less, we have to add water. Then to balance hydrogen atoms in acidic medium, add H plus ions in a deficient side. That means where H minus atoms are less. Then in basic medium, add H2 molecule where hydrogen atoms are less, and add equal number of atoms in opposite side. Opposite side. Then these all notes I am going to send your WhatsApp number. Then neutralization the charges by oxidation electron. Then to cancel out electron, multiplying the equation by suitable integer. Add two of reactions, then it will form one chemical equation. It will form. Then redox reactions as the basis for titrations. Actually, redox reactions. What is the use? What are the main important of redox reaction? Redox reactions main important for the basis for titrations purpose. Actually, basics for titrations. Redox reactions not there, then we cannot do titrations properly. That is why this redox reactions helpful for titration purpose. It is helping. Okay. Then what are the procedures? These all we will discuss next class. Then I am going to stop. Thank you, everyone. Actually, it is a very uh, if possibility there. I whenever we are arranging board, then properly you can understand. But one I think one student, my student, he asked. That is why I took this class like this manner. Okay. Thank you. Thank you, everyone. Good night. Good evening.